So all of us are familiar with this aspect. When you design a power distribution system, what comes first? Safety is always the number one priority. Safety of operating personnel and plant assets. Wherever you are based, that's the first priority. Everything follows later. The second most important priority with most organizations is reliable supply, continuity of power, and the third priority is adequate quality of power. There's no point having steady supply, but if the voltage fluctuates or the frequency fluctuates, well, it's not good enough. So you don't want voltage flicker, sags, or harmonic issues. Does everyone know what harmonics is? Has anyone heard of harmonics before? Yes, excellent. Harmonics pretty much are multiples of fundamental frequency. So, yes, all of you are roughly correct. So, harmonics are multiples of fundamental frequency. So, say for example, if we draw the fundamental frequency for a 50 Hertz system, a 50 Hertz system would have a cycle time of 20 milliseconds. Why is that? Because 1 over frequency is 1 over 50, which is 20 milliseconds. Alright? Harmonics are multiples of fundamental frequencies introduced by loads such as switch mode power supplies or rectifiers or some other loads, your arc furnaces. So a third harmonic would be 150 Hertz, which means for one cycle of fundamental, there would be 3 cycles of the third harmonic. So you might have something like this. Forgive me for the sketch. So what does that mean? Because of this, you'd have 1, 2, and 3 cycles within the one cycle. So the resultant waveform, if you draw the resultant waveform, that will be distorted. So it will be, might be something like that. Alright? So the resultant waveform is distorted. So it's the distortion of the power frequency main waveform due to harmonics. It can be third harmonic, fifth harmonic, seventh harmonic, and so on. The predominant harmonic in most systems is third harmonic. Right? So you don't want issues with harmonics, voltage flicker or sags, and you need good efficiency, low losses. Now transformers inherently, what's the efficiency of transformers typically? Whether it's distribution transformers or power transformers, what sort of percentage efficiency do you see with transformers? Typically, they are 99% efficient, 98 to 99%, alright? Most transformers these days, Ramesh, would be 98 to 99% efficient, alright? In common distribution sizes or power transformer sizes, they are the most efficient equipment. So there is not much room to improve efficiency there. However, with your loads like motors is where you can have more energy efficient motors, or even with conductors. Now, what's the relationship between area of a conductor and the resistance? Larger the area, smaller the resistance, correct? So sometimes you might have to use a bigger conductor in certain applications to reduce the resistance. Because if your resistance is lower, your I squared R losses reduce. Your voltage drop, which is I into R, also reduces. So some ways of improving your efficiency is choosing more efficient equipment like motors, because your transformers are almost 98 to 99% efficient, or choosing bigger conductors or other equipment that's more efficient. The consumer's responsibility, remember, as a customer, you can't expect everything to be 100% from the utility. There will be occasional issues. So consumers should know supply behavior and parameters. and preempt problems by proper design and selection of consumer-owned equipment. For example, if you are running a factory, your equipment needs to be rated to run at slight under voltage and slight over voltage. You don't want equipment that can only run at 100% of voltage and malfunction for anything else, because there will be some variation to voltage. There might be small variation to frequency even. So minimize adverse impact on power supply system. And as a customer, your responsibility is to ensure you are not introducing too much harmonics, because the utility will suffer, utilities other customers will suffer. Or you are keeping your power factor close to unity. Is everyone familiar with concept of power equation and power factor? Power in simple terms is square root of 3 times voltage times current times cos phi, where cos phi is power factor. Everyone familiar with this equation? Now forgive me, through the class I will ask some fairly simple, dumb questions just to gauge the level of background of all the students. You might be really familiar with these terms, but just to ensure that everyone is familiar with the basic terminology, I will ask some very simple questions. So this term here is power factor. If your power factor is poor, your current rises for a given power, and larger the current, higher the losses, higher the voltage drop. So you want to keep power factor closer to what value? What would be the ideal power factor? So what kind of problems are usually caused by utilities? This is not industrial problems. What sort of issues do you generally see with what the utility supplies a factory or an industry? Some examples of problems. Brownout, yes. Voltage flicker, voltage sag, over voltage, transients. Okay. And what kind of problems are attributed to loads within a facility? Within a factory, you have various loads. What kind of problems? Harmonics, if you have electronic equipment. Lower power factor, for example, if you have too many inductive loads. Starting of heavy loads, very good point, where a motor without a soft starter or a VST can draw a large current, which can cause voltage drop. Good. So types of power distribution. A utility has dispersed loads, which can be a mixture of large and small loads. Residential customers, generally small loads, single phase, and you have seasonal and daily cycle. All around the world, you have a seasonal cycle, summer season, winter season, and so on. Commercial or business enterprises, you have similar nature to domestic, but a different daily cycle. Most of the consumption is during the day, not much during the night. And industrial, larger loads concentrated in small area, load fluctuations depending on the process. So industrial distribution comprises of an incoming section. You might have a standby generator. Some industries have it, some don't. A primary distribution system, which can be medium or high voltage, step down transformer. Secondary low voltage distribution, control gear for controlling the system, and supervisory control system like a SCADA system. Main equipment types include circuit isolation devices, circuit switching devices, transformers, HV and LV distribution equipment, motor control panels, DC supply system. Why do you need a DC supply system? What's the key benefit of having a DC supply system? The key benefit is to provide power for your protection relays, circuit breaker tripping and closing, your control panel equipment, indication lamps and alarm systems, as well as your control system. You can run it with AC as well. However, the downside with AC, if AC supply fails, these things may not be functional. By having it on a battery bank, UPS, battery charger arrangement, you are ensuring that even if AC supply fails, power to your control and protection systems is functional. You have your relays, cable or overhead line-based distribution, earthing system, Power quality improvement equipment. For example, your capacitor banks to improve the power factor. So in terms of electrical safety and power security, electricity is a good servant but a bad master. Safety is a predominant issue. You have to comply with legislative requirements as well as standards, your national standards, IEEE standards, Australian standards, ANSI standards in the United States to ensure quality and reliability. And proper design, installation and O&M practices to ensure power security, continuity and quality. So voltage classification based on British standard and IEEE, which is also used in Australia and most other European countries. What's the classification of low voltage? Low voltage is anything under 1000 volts AC or 1500 volt DC. Anything over, technically or safety wise, is considered high voltage. Anything over 1000 volts AC and 1500 volt DC is said to be HV for safety. However, there is a difference which is not a standard based difference in industrial terminology. In industrial terminology, which also follows from IEEE 141, low voltage is up to 1000 volts, so similar to the last one. But anything over is HV, but you have two groupings. Between 1000 volts and 100,000 volts, so 1 kV to 100 kV, it is medium voltage. Anything over 100 kV is high voltage, up to 230 kV. And anything over 230 kV is extra high voltage. So you have these further groupings. But technically, anything over 1000 volts is still high voltage. Is everyone familiar with these terms? This terminology, groupings. Excellent. So distribution and utilization voltages. Most of your domestic and small industrial loads, offices are low voltage. Utilities can run at medium voltage or low voltage. Large industries, MV and LV again. Sometimes in industries you can have more than one voltage. Some options for industries, receiving and distribution at the same voltage. So you might have just a direct low voltage supply from the utility, which saves you costs on the transformer. However, there is a downside. Lower the voltage, higher the current, higher the losses, poorer the voltage regulation. And you may not, in terms of your independent earthing, it's not easy. You can still have earthing, but you are interrelated with the utility earthing. On the other hand, you have another option which is more expensive but might save you in the long term. Receiving at a higher voltage, then use a transformer with a on-load tap changer to control the voltage. You can have independent earthing, independent of what the utility does. Transformer acts as a buffer for harmonics or voltage dips. So receiving at a higher voltage, then you are stepping it down. For bigger loads, bigger plants, you use this arrangement. So you can receive 11 kV, for example. You might have some loads that need the medium voltage, and then for LV consumers, you have a transformer, step down transformer. Or you might have higher voltage with an on-load tap changer. You might have a substation. This symbol is for an on-load tap changer. This arrow, on-load means you can change the tap on-load when the transformer is on. While here, it's an off-load tap changer. You need to turn off the transformer to change the taps to regulate the voltage. Here, it's done when the transformer is on. So that's the symbol, arrow. For lower voltage, you have transformer, off-load tap changer. You have loads that can run at 11 kV. Large motors typically might run at medium voltage because higher the voltage, smaller the current. When the current is smaller, what happens to your voltage drop? It reduces. What happens to your losses? It reduces. So the system voltage is not affected much. If you run your motors, too many motors on low voltage, at low voltage the starting current is quite high. That can significantly impact your voltage. And because of the under voltage, other loads can suffer as well. Some of the motors may fail to start. So what are the problems that you can expect due to starting of large motor on other loads? Well, when a large motor starts, if it is on DOL, direct online starter, DOL means direct online, what's the typical starting current? In terms of normal range, typically what's the range of starting current? So because of that, there is a large voltage drop which can cause voltage dip, flicker, issues with other loads and other motors. With soft starter, it might be 1 to 1.5 times. With VST, you can regulate it to almost 1 time. But these are all expensive options used for bigger motors. We also have other starting methods, auto transformer starting to reduce the voltage. You have star delta starter, which also apply the star voltage. And they can give you anywhere from 3 to 4 times starting current. So large motors fed from intermediate voltage bus, so directly fed from 11 kV so that your voltage dip is lower. So you might have different voltages for different motors, different ratings. So LV distribution with multiple levels at the same voltage, so you have 415. What is MCC? Motor Control Center. You might have smaller motors powered from this panel, power distribution board, 3-phase and 1-phase LV loads, main low LDB, low voltage distribution board, lighting distribution board for lighting, sub LDB for lighting fixtures. This is your power control center. So this is your distribution, low voltage distribution.